First video of our video series on class hierarchies and interfaces, which is chapter 12 in our textbook. And these are the slides right here for chapter 12. And in this video, I just want to get through the first 10 slides. And while we go through these, we're also going to be revisiting this project from chapter 4, which was called Balloons All Kinds. And I'll just run it right here to remind you of how it works. If you run the main method in the balloon draw class, it will pop up this canvas with a pretty simple menu, and I can draw a round balloon, and anytime I draw a balloon I can resize it by grabbing the edge, and I can move it around by just clicking and dragging it around in the middle. So just to give you an idea, I'm going to change the color here and make a different type of balloon, an oval. I can move it, I can resize it, and maybe a different color for a square balloon. And again, resize that thing. And so one of the things to notice that's interesting about this program is that there are certain things that we can do with every single balloon. We can resize it and move it around. And then there are things that are specific to the type of balloon, like how you might draw a round or an oval or a square balloon. And so what we want to do with our code is organize it in a way where all of the stuff that is generally done to balloons and that balloons have is stored here in the balloon class, and then all of these other subclasses, we'll call them, have just the code that's specific to those particular types of balloons. And that's really what we're getting at here when we talk about a class hierarchy, which is, by the way, the heart of object-oriented programming, as it says here in the comments of the slides. So these are the objectives for the entire chapter 12, but we're just looking at class hierarchies today and abstract classes. This is probably the simplest example of a class hierarchy. It's just a base class with one subclass, and the subclass extends the superclass, and we use that keyword extends in Java to do that. So and the important thing to notice also on this slide is the introduction of this is-a relationship, which is to say that the subclass is an object of the superclass. And let's see how that works in our balloon program. So the round balloon, as we see, extends balloon. And what that means is round balloon is a balloon. And notice that we've got a couple of constructors here, and they just call the super constructors that are in the balloon class, actually. That's what that word super does right here. And then we have this one method, the draw method, which describes specifically how you draw a round balloon. And all the other stuff that balloons do is over here in the balloon class. So if we take a look at we'll talk in a little bit about this word abstract, but the balloon class has some instance variables, a center and a radius and a color. And then there are some constructors here that describe how to make a balloon. And then all of these access methods, the get methods for all of the instance variables, or fields as we call them. And then we have a distance and a move and a set radius and an isInside method. All of those methods are implemented here in the balloon class. And at the very bottom there's that word again, abstract, and that's the draw method. So we're going to talk a little bit about how we sort of constrain our base class here, the balloon class, with this keyword abstract. But let's just go back here and take a look at the class hierarchy that they've given us in the slide, and it shows us that um, it really shows us how we can build some really rich and complex hierarchies in object-oriented programming. In this example, the birthday balloon and the hot air balloon are two different types of round balloons, so they must extend round balloon, and round balloon extends balloon. So these classes down here, they are balloons, to be clear. So a hot air balloon is a balloon. It's also a round balloon, and it has access to all of the functionality of the round balloon and the regular balloon through this hierarchy. And we get a couple of important improvements from these class hierarchies. We write better code when we use them, because what we really are able to do is encapsulate all of the basic stuff about balloons in the balloon class, and then the only thing that appears in these subclasses are the things that are specific to these types of balloons. And so we take all the common code and put it in one place, and that keeps us from cutting and pasting from one class to the next. So if you find that you are cutting and pasting from one class into another, that might be an indication that there's a better design choice to be made in your class hierarchy. So one of the so just going back here, this is keeps us from duplicating code, and that's one of the important things that we get from this class hierarchy. The other thing we get is a more general way of accessing objects. For example, I might want to, in this example, we add a balloon, and I might just want to add any type of balloon, and it doesn't matter. And we actually do that here in the drawing panel. Notice something's going on here. Gonna close this and reopen it. If we look at the drawing panel code, it's a bit of a mess. There we go. Not sure why that happens, but notice the very first line in this drawing panel is an array list of balloon objects. And so any subclass of the balloon class will be able to be stored in this array list. And that's helpful because, as you saw when we were running this program, we had several different types of balloons that we added to this canvas. And we want to be able to do that. And our class hierarchy lets us do that. So going back to the slide, we see that instead of having a different method to add a round balloon and a different method to add an oval balloon, we can just have one method that does the same thing regardless of what type of balloon we have. So that's an important benefit also from building a really well-designed class hierarchy. So let's move on to this word abstract, and notice in the balloon we have this abstract method in the balloon class, and I'll just go back there, and when we use that keyword abstract, we actually end our method declaration with a semicolon, and we don't have any braces to open and close this method. There's no method body in an abstract method. In fact, all it is it describes the structure of the draw method, but there's absolutely no implementation of this method. And by using the word abstract, what we're saying is that any class that extends balloon has to implement this draw method. And that's also why the balloon class itself has to be abstract, because if you have even one abstract method in a class, you have to declare the method as abstract, because there's no actual implementation of the draw method, so this balloon can't draw itself. So this offers a very necessary constraint here, that We put all of this functionality in the balloon class, but you can't actually make a balloon object um, without first designing a subclass that implements this draw method. And so we can still include all sorts of concrete uh, methods inside the class, but again, um, if we want subclasses to implement the a particular method, we make it abstract, as we've done here. And so, a couple of points about the abstract classes. Um, Generally, it gives us a way to make a place to put all of the common functionality for a bunch of specific classes. And the abstract method, the draw method in our balloon case, provides an opportunity for the compiler to do an additional error checking, right? To just if you forget to implement an abstract method in your subclass, you will be reminded by the compiler that you have to do that. Um, and just moving forward here, there are a bunch of abstract classes in the this swing framework that is used to create those little applications that we sometimes use in the class. And then finally, a few things that we should just acknowledge about abstract classes. Java doesn't allow us to actually create objects of an abstract class. I mentioned that earlier. And that's because if you just tried to make a new balloon object, that balloon wouldn't know how to draw itself because it doesn't have an actual implementation of the draw method. They can still have constructors, even though you can't actually construct one, but those constructors are used by the subclasses. And that's why they're there, is again to like capture all of that general code that all the different types of balloons are going to need to do in order to build themselves. And then most of the classes we've used up until now are examples of concrete classes. That is, there's no abstract methods, and so that is just a plain old concrete class. And that's it. So now you should have some idea about why it is that we would want to, in this project, create a single balloon class that contains all of the basic things that a balloon needs, and then all of these subclasses that just add specific functionality that's specific to each of the different types of balloons.